Somebody commented on my JavaScript Powers of 2 program and wanted me to explain it more briefly. Here's the thing though. For this video, I'm going to be showing my program in the C programming language and showing how it works. And part of that is I'm rusty on my JavaScript code, and I know it's on my hard drive somewhere, but finding it's going to be a challenge. I do all my programming now in C or C++. I mostly did C++ with SFML because you can't use SMFL in plain C. Well, there's a version for C, but never mind. That's another topic. See, I have a problem being brief because I say one thing, but then it reminds me of something. But what I'm going to do, as briefly as I can, I'm going to go over my C Powers of 2 program, which the algorithm, pretty much 90% of the code is identical to the JavaScript version, because I still remember that I wrote the C version, then I made a C++ version, which of course it was the same except replacing printf with cout and all that, and I made a Java version and a JavaScript version. I basically took the exact same code and copy pasted it to work with each programming language, with minor variations. There's just slight syntax differences, but you'll find that 95% of the syntax is the same. The only difference is the functioning between those 4 languages, pretty much, as far as the purpose of outputting text of Powers of 2. So anyway, I'm going to show you my screen. I'm gonna show, okay, it's showing my screen. And what I'm going to do now, there is a train outside driving me crazy. I'm going to show you what I have here. So I have my Sigwin64 folder, and I have several little projects in here. I've done tons of programming in my Sigwin environment. I also have MSys2, which I installed and it's just as good, if not better, as Sigwin. I could use either, but it just so happens that my Powers of 2 program in the C programming language happens to be in the it happens to be in the Sigwin folder already, so I'll just keep it where it is. Also, the BBM projects stands for binary bitmap, and BPM stands for binary pixel map. Those were projects I created, and I used like ImageMagick. I used some really sweet algorithms for some things. Anyway, I am going to go to my C folder, and I'm going to show you. See, I have several different folders. See, like here is a folder named 0, which I put things that I temporarily use. Like if I'm working on a project and I don't have a name for it yet, I put it in the 0 folder and compile and run it. And several other things. I have several other things here. I have my integer output library I wrote, all my own code. I have fhex, which is a thing I wrote. If I remember correctly, I think it displayed the hexadecimal of a. In fact, you know what? I hope you don't mind. I'm just gonna check real quick. I wrote this. This program reads or writes bytes of a file. Oh yes. Yeah, I remember I wrote that. Basically, all it really does, it can let you display the byte of a file and even write bytes to a file. I wrote that as a cool tool, although using an actual graphical hex editor is easier for everyone than my program, but I learned a few things. Anyway, I'm getting back on topic. So in the folder named 1 is where a whole bunch of my stuff is. This was the original folder of my different C programs, and I have several things. I have examples I wrote to remind myself how to use things. I have prime numbers, Powers of 2, memory testing, the hello world, Fibonacci, factorial, all of the binary counter named Bink. Whoa, that was so cool. Yeah, so I'm gonna show you something. So basically, I'm going to, the Powers of 2 program is what's extremely interesting here. And I'm going to show you, I'm going to use it. I'm going to create a new folder named POW2. And this is where I'm going to put my powers of 2 folder, my file, I mean. Okay, so here's what we have. I'm going to show you the source code, and I'm going to explain how it works. I'm going to try to make this my brief explanation because I have to be at work soon. So this will force me to be brief. So first I'm going to explain how the program works, and then I'm going to prove to you that it actually does work by compiling and running it. So basically, at the start, we have our header files. If you know C or C++, you understand header files like this have to be included. But each programming language has different ways of including the standard libraries. So these 3 variables here, which get their name from Minecraft, the coordinates screen, and the last letters of the alphabet, I named it I'm just obsessed with those letters now. Now, this, I wrote some comments, as you see. This length, how many digits the array can use, the maximum number of decimal digits in this case. And then this is length 2. This is how many digits are currently used, meaning it will, if that value is set to whatever number that's set to, will show how many digits it will display. Because if it's set to a higher value, it will pad with extra zeros, and I can show you. You'll understand when you see how the program works later. So basically, here's what we have now. First of all, I start out by allocating the memory, and it's a lot easier if you're in Java or JavaScript because you can just say new array or new int with a number. And you can do that in C as well. However, I allocate pretty much all my memory dynamically these days, with few exceptions. I use malloc to allocate an array, and I use free to delete the array. So we have an array named A. And so this first loop here, see, I'm going to highlight these. See, so that first, that allocates the memory. Now we're going to go down. And this loop is very simple. All it does is, after creating the array, it does a loop using the x variable. It goes to the length of the array, which is going to be equal to length. Because remember, we're doing using malloc, allocating the length variable times the size of the variable pointed to by the a pointer. So it's going to be exactly 64 bytes. So in other words, it sets all of these to 0. See, because what we have here is we have the x element of the A array equals 0. And then after that, after the loop is over, it sets element 0 to 1. Because remember, we're doing powers of 2. So the first digit is going to be 1. Now here's where it gets interesting. Here is a loop using the z variable that is meant to go exactly, technically it goes exactly 65 times because it starts out as 0 and then it goes while z is less than or equal to 64, and you'll see why I like that in a moment. So, and now this is a very important loop. This loop right here, this loop is only for the purpose of displaying the digits. Because what it does is it takes each element of the array, it indexes them from the end of the array to all the way to the 0 element. So it's doing them backwards, and that's important. Otherwise, it doesn't look right. And of course, it decrements x. Now, printf. Anyone who's done any C programming knows that printf is like the ultimate function. How could anybody write a C program without a way of putting output? So printf is nice. You use document.write in my JavaScript version that person commented on, but the idea is the same. So we're printing the integer of that element of the array, and then after they're all printed, we print a new line. So it goes to the next line in the console. And then we have the y variable. It starts at 0, and we have a new loop. Now the reason that this y variable is actually used as a carry variable. So here's how it works. Basically, x is going to index all the way through length 2, which is, it's only, length 2 is currently 1 the way this is set up. That means it's going to go through all the digits that are currently used. There's only one digit used at the start, and then it adds that digit to itself. So in other words, if it's 1, it becomes 2. If it's 2, it becomes 4. If it's 4, it becomes 8. But if it's 8 and you add it to itself, it becomes 16. But that takes more than one digit. So here's what it does is it adds the carry at the start, which is 0. But here, this is the key. This right here, this line that I'm highlighting where the cursor's at, is the key to understanding the whole program. Really, because if that element of the array is greater than 9, we're going to require an extra digit. Therefore, we're setting y to 1. We're setting the carry variable to 1. And then it subtracts 10 from that element of the array, so it will fit back into a single digit. So after you double 8, it becomes 16. So this array element becomes 6, and y becomes 1. And notice that if it's not greater than 9, then the carry becomes 0. Now there were other ways to write this, because I could have used like the modulus operator. I could have done something fancy with division. There are other ways to do this. Like I could have had the carry variable equal, that element divided by 10. Because that would work just the same. But I wrote it this way so it's easier to understand. It helps me remember how it works, and it helps people who are less experienced in programming understand how it works. And I think that writing code that others can understand is one of my greatest challenges. But trust me, people, I'm working on it. I want people to understand why my code works. Okay, now here's the thing. Notice what it does here is if the element at the current length 2 variable is, if it is greater than 0, that means we want to make sure that we display this digit. Therefore, it simply adds 1 to the length variable. And then, after all that, it frees the memory and returns 0 to the operating system, which just means the program worked. So now here's the thing. What you see here is that I have the command which compiles and runs this program right here at the top. So here's what I do. I'm going to copy this command because this command works. And you'll see why. So what I need to do now is, first of all, let me make sure I'm still recording. Yes, I'm still recording. That is great. Now, I'm going to open my Cygwin terminal, and it gives me a little message. Hello, Chastity. Welcome back to Unix. And I customize like the message that it displays. It's really cool. And yeah, so here's the thing. I do ls, which now remember that like if you do dir in DOS, it does that, but ls is like the Unix way. It displays all the folders and files in this directory. So I'm going to do cd, change directory, C, and then I'm going to change directory to the pow2 directory. And here's what's great. We see the power2 file is there. Here's what's great. If you're using a terminal emulator inside a Windows operating system, because remember, I have a mini. What I'm inside here is I'm inside a mini Unix system running inside the Windows operating system. So what I'm going to show you here is I'm going to paste that command that I copied from the text editor. It works. And see, here's why I'm going to run this program, and you'll see what it does. It takes a little while to compile and run for some reason. Yes, it worked. You see here? See, it's very interesting because the program, it compiles, and you may not understand. Basically, I will just explain the compiling options very briefly. WAL is Warn All. ANSI means the American National Standards Institute, the standard that they created back in 1989, actually. And then pedantic means it's just very, very picky. Okay, so it had basically the new C compiler with those options, and then the name of the file, and then that compiles it to a file just named A. The default is A. And then the I have the two ampersands. That stands for and then another command follows it. So what you see here is, if I go back to folder, notice that we have an a.exe file here. And it's interesting, it doesn't run outside of the Cygwin environment normally. But so now you see, if I go here, all I have to do now is type A. Wait, oh, that's right. I have to do. See, you normally can just like type A if you're on Windows, but on Unix it's different. You have to do / and then A. Come to think of it, what happens if I do /A? Nope, it doesn't work with the backslash. Yep. So /A. So here's what you see. You see the program works. It totally works. And why does it work so well? Well, it's very interesting, because I just tried to explain the entire source code and how it works. And as you see, these are the decimal powers of 2. These are exactly the decimal powers of 2. And so you see, we got, hopefully you can see this. I hope my video quality is good enough that you can see all of these things. But basically, that is what we have here. So now that we have this, I want to also do something else. Now, normally I run things with make. See, I can't use the make command. I'm going to show you something a little bit interesting. I'm going to delete that, and I'm going to create a make file for my C project. Now, this doesn't have anything to do with how the program runs, but it does make compiling and running programs easier. What I'm going to do here is I'm going to take this to the POW2 folder, and I'm going to edit this make file. And I'm simply going to change these commands here. Okay, I'm going to remove all this stuff because none of that is actually important. Wait. Oh, I see how it works. Yeah, okay. Right, well anyway, I'm going to show you something. So the name of our project will be Power2. And what I'm going to do is I'm going to just do a few things. I have power2.c. The output file is going to be power2. Okay. So basically, okay, so now I had to catch my breath. So basically, that is my simple make file. And now that the make file is in the same file as this, I'm going to type make. See what it does? Wait, main command. Oh, I see. I made an error in my make file. Okay. Okay. The name of the program now has to be Power2. And you'll see why, because what it does is it creates power2.exe. So that's the thing, is the make file almost worked, but I had a small error. So now, instead of typing a long command in order to run my program, all I have to do is type make again. It says Power2 is up to date. What? Okay, that's very strange. I wonder why that is. Oh, I think, you know what I think? I think it only changes it if I edit the source code. But anyway, let's run the program power 2. It works perfectly. So now here's what I'm going to show you. First of all, I'm gonna slightly just change my command that's in the source file. I just wanted to show you the power of the make file. I'm just gonna change this. Okay, so now I'm going to show you how things can be changed in this program. This program can do all kinds of amazing things. I only have a few minutes. I need to be leaving here soon. But here's the thing. So let's say if I change the length 2 variable to 32, how many digits are currently used? And then, now that I've made that small change, let's type make. It still says it's up to date, which is strange. That's kind of odd. I'm not actually sure why in the world it does that. Oh, I think I know what I need to do. Yeah, I think I may have figured something out. Yeah, okay, yeah, just ignore this part, people. This is, yeah, see, because you put the name of the source files involved when you are trying to, because the Power2 project uses power2.c, and now that the power2.c file has been updated, maybe make, yes, it works. Yeah, see, it says it's up to date. It compiled and run it because there was a slight change. So see, the make program is smart. Trust me, once you learn how to be more proficient at it than I am, you definitely want to use make. But see, now that I set that variable to 32, it's all lined up because it always displays 32 bits. Now here's the thing. Let's say that I change it to 16, and then I do make. See, now it changes it. Notice that it displays exactly 16 digits until more digits are required, and then it starts adding digits. See, that's the brilliance of my program. That is why my program is so brilliant. So you see, let's say I just set the digits to 64, and if I set this variable to a higher number, let's say I go to 128, it will display up to 2 to the 128th power. So see why I made a separate folder for this, because I knew I was going to be editing it. Okay, so now see that last number shown there is 2 to the 64th power. But now we're going to do make again. And yes, it has gone crazy. Wait, make file power2 aborted, core dumped. I think I may have exceeded the number of digits allowed. Okay, that's just a little bit weird. I wonder what's up with that. I think there were probably too many digits to fit into the 128th power. So here's the thing. I know what I'll do. I will simply increase the length variable here. That should be fine. And I'm going to set this back to 1. I think I had a memory allocation failure. That can happen sometimes. Okay, so let's see. Oh yeah, see, it works. Oh, that's weird. See how that works? Yes, it's working, but I'm still not sure why I had a segmentation fault. Strange things happen. So in other words, my program doesn't really have any practical limit. I mean, you can literally, just by changing this number, my program will display starting from 1 up to 2 to that power. So 2 to the 256 power. So let's type make again. Yay! It's so cool. Is this not cool? Like, if you don't like this integer sequence, like, how in the world how do you live? Like, seriously. This is so cool that I'm just gonna I'm just like totally gonna copy paste this text. Seriously. Because this is just amazing. I love this. Yeah, I'm just gonna copy this. Yeah. Yeah, I'm good. Yeah, I know this is funny, and I know that I wasn't as brief as I should be. I hope that my explanation, if you go to the part where I explain why the program does what it does, then you'll see. And if you have patience, you can see how I compile and run it, because I'll tell you, I can just totally tell you that the installing a compiler and learning to run the compile and run the program. You have first, okay, I'm gonna exit out of this, and I'm done showing my screen for now, so I'm just gonna exit, and then I wanna quickly, in closing, a few things I want to say. The hardest part of being a programmer is first, you have to know how to use a computer. Then you have to install the right tools. So, for example, you need to install a C or C++ compiler for programming in those languages, and you have to install the Java Software Development Kit, the SDK. And I used to have that. I don't have Java installed right now because I haven't really done Java programming for a long time. I prefer C. But it's similar. In any case, so you have to install these tools. Now, the only way out of that is you can use JavaScript, which is the original language which that comment was directed towards. But that's the thing, because web browsers already interpret JavaScript, so that's great. But C is a very much more rewarding language. If you do C or C++, which has more features, if you want to be a game programmer, my best advice for you is probably going to be to learn C++. Even I haven't learned much of C++. I still do mostly C, because I get like 1 day a week to work on my programming, which is really, really sad, because I have work, and then I have my mother yelling at me all the time about something, it seems. But anyway, so that's the thing, is, yeah, I tried to have a brief explanation of my Powers of Two program, but I also included the process of, I showing my source code, I explain my source code, and that's the most relevant part. That might be the brief part of the program. And then I showed the part where the program compiles and runs. And it's not as brief as it could be, but that was my second attempt at showing how it works. And I feel like I may have explained it better, but this certainly wasn't brief. Okay, anyway, I'm sorry I wasn't brief enough, but I am still very happy to show off my Powers of Two program, because it's one of my favorite programs I've ever written, and I'm very proud of it. So let me know in the comments if you have any more requests for programming videos, topics like how does a beginner programmer do something in C? Because I'm quite experienced with C. I've done it as a hobby, no formal training, but I've written some cool things in it, just that are simple enough to write. So because my skills are limited, I may be able to help new programmers that need some help with things. So my time's limited, but please let me know in the comments if there's a simple C program you would like to see written, because chances are I might be able to do it. So that's all for now, and I hope you've enjoyed this video.